A research loop I reviewed had a checker at the end. The checker gave every draft a quality score from 1 to 10. Anything above 7 shipped. For 2 weeks it looked fine. Then a customer found a report with 3 unsupported claims and 1 source that contradicted the conclusion. The judge had scored it 8. Nobody could tell why. Was the citation bad? Was the reasoning bad? Was the summary incomplete? The loop had a number, not a diagnosis. The repair agent rewrote the whole report, burned budget, and often made it worse. The naive version of LLM as judge is ask another model if the output looks good. Sometimes that catches obvious garbage. It also creates a soft ceiling on reliability. A vague rubric makes a useless checker because the checker can only enforce what you gave it. 1 to 10 scores are especially dangerous in loops. A 7 can mean minor style issues, missing evidence, wrong format, unsafe assumption, or the judge was tired of being strict. Your orchestrator cannot route a 7. Your repair step cannot fix a 7. And 2 judges can both say 7 while disagreeing on every underlying reason. The pattern is checker rubrics. Write criteria that are binary, evidence-backed, and independent. Binary means each check returns pass or fail, not a mood. Evidence-backed means the judge must point to the exact observed fact that supports the verdict. A quote, a file path, a line number, a test result, a data field. Independent means one criterion should not require another criterion to be true before it can be evaluated. That matters because independent checks can run in parallel, fail separately, and map to exact repairs. In my opinion, this is the line between a demo judge and a production checker. Mechanically, start with the task outcome, then break it into observable checks. For each check, write a question with a yes or no answer. Then write pass if, which names the exact condition for passing. Then write evidence required, which tells the checker what kind of proof it must cite. Then write fail reason format, so downstream code can parse and display the failure. Then write repair hint, but keep it narrow. Add missing citation, rerun unit test, change schema field, remove unsupported claim. Finally, put a version on the rubric. Criteria drift is real. If you change what counts as passing, old judge results are no longer comparable. Take a research loop that drafts a short market brief. A weak judge asks, is this accurate and well cited? A checker rubric splits that into binary checks. Check 1. Every factual claim has a citation marker. Evidence rule. List each claim and its marker. Check 2. Each citation source contains text supporting the claim. Evidence rule. Quote the source sentence. Check 3. The conclusion does not introduce a new uncited claim. Evidence rule. Quote the conclusion and cite matching earlier evidence. Now failure is local. If check 1 fails, the repair loop adds citations. If check 2 fails, it replaces or weakens claims. If check 3 fails, it rewrites only the conclusion. This pattern does not make model judgment magically correct. Judges can still miss subtle errors, cite irrelevant evidence, or pass wording that technically satisfies the rule while violating the intent. Evidence rules help, but they do not replace domain verification. Another failure mode is overlapping criteria. If 5 checks all fail for the same root cause, your repair loop may thrash. Keep criteria independent and deduplicate failures before repair. Rubric drift is the quiet killer. Someone tightens a criterion, historical pass rates drop, and nobody knows whether the system got worse or the ruler changed. Version criteria and log the version with every verdict. Checker rubrics sit in the middle of loop engineering. Stop conditions need them because a loop should stop when required checks pass, not when the output feels done. Budget control needs them because some failures are cheap to repair, and others should escalate to a human or a slower verifier. State management needs them because each verdict, evidence field, rubric version, and repair attempt should be stored. Orchestration needs them because independent criteria can be assigned to different checkers. A schema checker can inspect format. A retrieval checker can inspect sources. A policy checker can inspect allowed content. The rubric is the routing contract. Here is the 10-minute exercise. Pick one automation where you currently ask, is this good? Do not rebuild the loop. Just replace that question with 5 binary checks. For each one, write pass if in one sentence. Then write evidence required. If the checker cannot cite evidence, the check is not ready. Then add 1 repair hint per failure. Keep the hints small enough that an agent or script can act on them without guessing. Last step, mark the rubric version as 0.1.0 and save 3 sample outputs with judge verdicts. You have just created the start of a regression set. 3 beats to keep. First, binary checks beat 1 to 10 scores when the result drives automation. Scores may be useful for dashboards, but loops need decisions. Second, every criterion needs an evidence rule. Without evidence, the judge is just giving you a confident opinion with no handle for repair. Third, version your rubric. Changing criteria changes the system, even if the model and code stay the same. A checker is only as sharp as its rubric. Make the rubric sharp enough that a failure names the fix. New loop engineering episode daily on this channel. Patterns, guardrails, budget, state, and orchestration that hold up under load.